For any steel structure, connections are the most vulnerable part, and we need to design this properly considering all factors and check whether it can withstand the critical most loading condition. For any industrial or commercial steel building like a plant or pipe rack structure or a PEB warehouse, there are thousands of connections which we need to design, including member-to-member, bracing or base plate connection. And to design any connection, we require the geometric data like section information, orientation, spacing along with the load data or member end forces. Based on this, connection design is performed. Do you know, if we model the superstructure in STAAD, we can automate the connection design during modeling without even assigning any connection template manually? Hello everyone, and welcome to this session on connection design with RAM connection. I am Surajit Ghosh, and today I'll cover the basics of connection design using RAM connection, its different modules, workflow, and integration with other software like STAAD. In this session, I'll start with some basics of connection design. What are the current trends and solutions available in the market? Then I'll cover different features of RAM connection. What are the different connection templates and design code available for design of any standard or custom steel section? Finally, I'll cover different modules and workflow of RAM which can be used for connection design. RAM connection has a standalone module. It is also integrated with different structural products including STAAD.Pro Connect Edition. I'll cover this later. First method of design is the manual approach. We can calculate the connection capacity based on the empirical equations and compare those against the actual member end forces. This will give an idea whether the assumed connection, plate thickness or number of bolts are sufficient for that joint or not. Well, it is extremely difficult and time consuming to design all the connections manually. It might take days to complete the design. Also, it is quite hard to identify and group similar type of connections manually in a large model. That's why for any medium to large scale project, manual design is not an ideal solution. Second method and one of the common alternatives is an in-house application which can design different common types of connection based on user input. I know some of you are already using this type of application. Though this is more efficient than the manual approach, there are some limitations for which it is not always an ideal method. One of the challenges is to develop this template based on the codal provision and user input. And when a new version of the code is published, we need to redevelop this for that version. But the major challenge is to feed the data which is required for connection design. We need to extract all required data from the analysis model, including section forces, property and member alignment, release condition, and provide this as a user input based on which connection design is performed. This entire process of extraction of data from the structural model and provide it in the design template is a repetitive process. For each joint or connection group, we need to perform same steps and there is a high chance of manual error. Also, these in-house applications normally provide the design results in a tabular format or as a text file. We need to manually generate the drafting drawing based on the design results. There are several other limitations. Obviously, some of this can be eliminated with advanced coding, like we can use different OpenSTAAD function to extract required information from a STAAD model, including member end force, section property or specification. Still, we are not fully utilizing the data which we have already used during structural analysis. There is no direct data transfer between the analysis model and connection design tool. To minimize this repetitive work and reuse the structural data for connection design, we can use an integrated solution. And this integrated method of connection design is our main topic for today's session. How we can use RAM connection to design any connection directly using analysis model without providing any additional input. By the way, RAM connection is the only software in Bentley's structural portfolio which can perform steel connection design Previously, there was another software, Limcon, with similar connection design feature, but it has been discontinued now. All the features of Limcon have been merged in RAM connection. There is also an option available in RAM using which we can easily import any old Limcon model and perform connection design using the latest version of code like AISC 36016 or Australian code. Anyway, it's a different topic. If you need any information related to Limcon, let me know in the comments. RAM connection has different modules for connection design, and it is important to select the correct module for any project. It has a standalone module, which is nothing but an isolated software without any integration or data interchange option. We can use this for individual connection design by providing few information like geometry, section size and alignment, end forces, and on basis of this, a specific connection is designed at that joint. Though it is similar to any in-house application, RAM has several useful features like auto-generation of drawing and report. I'll cover this in detail. Apart from this, RAM connection is also integrated with other analysis software like STAAD.Pro Connect Edition, RAM Structural, and RAM Elements. If any of this software is used for analysis, RAM can import all required information for connection design, including geometry, section, load, and member forces from the analysis model. No manual input is required, and we don't have to repeat the modeling or load assignment. In this session, I'll cover the standalone mode and integration between STAAD and RAM connection, how to use the analysis model for connection design, finally, how to edit any connection data and review the design results or drawing using connection pad. All these modules use a single license. Separate RAM connection license is required to use the standalone version. It is also used in the integrated connection design module of STAAD and RAM. By the way, RAM connection is already included under structural worksheet. For STAAD.Pro Connect Edition, from the license configuration window, we need to switch on the license of RAM to use all the modules of connection design, including smart templates and cassette connection. Once it is selected, a green light is displayed in the welcome screen. Without this RAM connection license, we can still design few types of connection in the integrated module with basic STAAD license. It is limited to AISC 360 code. Only basic connection templates for few types of beam column flange and web connection, like CR end plate or flange plate connection. Rest of the templates or design codes are not available with the basic license. If we try to use a smart or gusset connection, an error will be displayed. A detailed list is provided in the help manual. Most of the major design code used in any structural project is available in RAM connection. For American code, different version of AISC 36016, 10 and 5, both LRFD and AST methods are available, along with AISC 341 and 358, which are used for seismic provision check. There are few specific requirements for high seismic zone like max number of bolt row or stiffened extended end plate connection. These are considered during connection design. IS 800-2007, latest version of Australia, New Zealand and Canadian codes are already implemented, along with different annex of Euro code. For Indian code, seismic provision check based on chapter 12 is not yet implemented. During connection design, two different design approaches followed. These are categorized as basic connection and smart connection. If you are familiar with RAM connection, probably you have noticed these options either in the standalone version or in the integrated module. The design logic as well as the template name and inputs are different. We need to finalize correct design approach based on our requirement. For basic connection, all information of the connection is predefined, and on basis of that, program computes the connection capacity and finds out whether the user-defined connection can withstand the critical load or not. Accordingly, pass or failure status is reported along with the utilization ratio. Program does not suggest any modification or optimize the connection, though manual optimization is possible. We can use multiple connection templates with different plate thickness or bolt number like 2, 3 and 4 number of bolts. During design, most optimum connection among this predefined template is selected. This method is used when we want to use company or project specific guidelines or pre-selected templates for connection design and checking. As you can notice here, every detail of the connection is predefined. It is an in-plate beam column flange connection selected from the Indian database. 6 mm thick plate with 2 number of bolts of grade 4.6 is used for this connection. This is not proper optimization, rather selection of suitable connection. For optimization, we need to use smart connection. Here, no other connection information is required except the connection type, like it is a beam column flange in-plate connection designed with IS 800-2007. During design, program performs several iterations by varying different parameters including plate thickness, bolt number and grade, type of weld, and based on the critical force, most optimum connection is suggested with utilization ratio close to 1. Though smart connection is more economic, still it is not always preferable. If there is any project specific restriction for plate thickness or bolt, we need to go for basic connection with manual optimization. By the way, RAM connection is not a finite element based software. No FEM model is generated or used for design. Rather, it is based on the empirical equations available in the design guide. For AISC, design rule and equation for almost all connection types are available in the code, and all those different connection templates are implemented in RAM. But there are several other codes like IS 800 where design rules are not clearly mentioned in the code. In such case, either other international guides are used, reference of which is mentioned in the output file, or the template is not implemented in RAM. That's why few templates are not available for Indian or Euro design code, though it is available for AISC. In next part, we will explore the connection database available in RAM, different connection templates for shear, moment and combined connection, including beam column flange and web connection, beam girder, splice and baseplate connection. Also, I will discuss about different connection design workflow and selection of correct workflow. Stay tuned and keep watching.